Okay. So not all electrochemical reactions are exactly at, if you want to use the table, what concentration? Standard conditions. To get the little E0 on E0 cell. Concentrations of everything had to be what? What molarity? One, right? Pressure of 1 atmosphere. Okay. So we're not going to mess with temperature. That's essentially room temp, so that's fine, 25 degrees Celsius. But look at inside the little brain of a, what is that, a pigeon, right? Or a brain of a human, or people, or electrochemistry is all over the place. And it's really sensitive if you can get the right, the right reaction you're interested in. Electrochemistry involves a lot of different reactions and some complicated things. So you could monitor some really complicated and complex biological systems. And it seems kind of intrusive, though, right? You have to jam those electrodes into objects, but who knows, right? Things are getting better. Like, look at the diagram up here. This doesn't seem so bad. These little wires can fit through your skull or something, right? Kind of like what's going on here. So it's useful stuff. But the point is that what it's detecting and what's going on are not at standard conditions. So you can't be using those tables to get your answers. Here it is. Just kind of modified a little bit. When an electrochemical cell is at equilibrium, we've seen this. This is what we've been working with, right? Or it's not at equilibrium, or not under standard conditions. Here's the interesting one, right? The Nernst equation. We're not at equilibrium, not at standard conditions. E0 cell is still in there, though. How do you find these variables? How would you get E0 cell? From the table. From the table. This stuff. You're going to need a much bigger table. Or find out what E0 is yourself. Set up standard conditions with glutamate, right? And see what the half reaction is. And measure the standard potential. Make your own table. So you can get these E0 numbers. Okay. So remember, to get them, you pretty much have to write the what reactions? What are they called? The half reactions. And you get those from the tables. And you get the little E0s. Remember the game? You have to arrange the half reactions so that when you add them up, you get the most what E0? Most positive. And another trick is, oh, dang, what has to cancel? Electrons, right? Let's play a little game. Make sure you're following. Let's say this half reaction had 3 electrons. This one had 4 electrons. Yeah, 12 is going to be what's going to be canceling. Does everyone see it? Top one would be times 4, bottom one times 3. So 12 electrons are going to be canceling. The reason why I'm going through all that is, where does the 12 go? On the end. There it is. That's why I'm going through all that. That's what your little n's are going to be. It could be it's the same little n. Okay, number of electrons that cancel. We've seen Q before. Oh man, here's brownie points, Marcus, if you can remember what we called it. Start with an R. We used it to predict whether you were at equilibrium or not. Anyone remember? Reaction quotient. Reaction quotient. All it is, it's a K expression, right? Products over reactants. Except they're not at equilibrium, so they don't write K, they write Q. No big deal. Okay. Same thing, yep. Okay, but technically, you write Q because you're not at equilibrium. So that's how we find all the variables. And we're good to go. I think the only thing stopping us is the math. So let's practice this. You saw how to get all the variables. Like, right, in this question, this little 6 came from where? Just so you remember this. This little 6 came from the electrons that canceled. How about this stuff? Where did this stuff come from? Mm-mm. Remember what this is? This guy right here. Products over reactants. They're what? They're concentrations. How about this? Where did these guys come from? Yeah, those things in front and their overall chemical reaction. That starts with an S. Stoichiometric coefficients, right? But you see where this is all coming from? So you're going to plug all this stuff in. Hey, where did this guy come from? The tables, E0 cell, right? You had to add these guys up. So the electrons that canceled, that was the 6. The little stoichiometric coefficients, that's these guys out in front, right? The numbers out in front of your compounds, right? Whatever it is. That's what those are. Okay, so there's a lot of work to get this. But what I'm saying is you don't want to go through all that work to set this up and then screw it up on your calculator, right? So let's see what number you get. What's that? Yeah, they have to tell us those. That's true. That's not going to be a whole lot of work. They're going to tell us the 0.01 molar and the 0.25 molar. They'd have to. You're right, Jasmine. They're going to have to tell us those. But everything else we got to figure out. So we plug it all in, and you get what? Solar calculators. You're going to need light. Now, what part of this equation should you probably do first? The log part. I would definitely do the log part first. Right. So let's kind of erase some stuff here. Get some steps. There is a cube button. You have to do shift first. Squared. I got what Brad got.
What did you get, Brad?
Brad. 0.397. Okay. Now see if you can get these intermediate steps here, right? Inside the log, I got 1.6 times 10 to the negative 5. Then you got to push the log button. Times 0.0592. That should be a point, right? Divide it by 6. Hit equals, and you'll get the 0.047. Because the log guy must be negative. So a negative and negative makes a positive.
Why wouldn't you, after you get the log, just do a cross multiplication?
This is going to be a number, right? Take it, divide it by 6 times 0.0592. There's no cross multiplying. This is an actual. You have to do this. It's 0.0592 times the log divided by 6. So you're not solving for a variable in there. Make sure the folks around you got it. Just help them on their calculator if they're not getting it. Bianca, you got it? No? Where'd you mess up? Okay, 0.01 shift cubed, right? Divided by 0.25 squared equals. So maybe your trouble is in here, right? To get the 1.6 times 10 negative 5, 0.01, raise it to the third power. And that's, you have to push shift to get it. 0.01 shift x cubed divided by 0.25 and then square it, x squared. But don't push shift. Then equals 1.6 times 10 negative 5. Okay? You comfortable with it? Okay.
I'm kind of confused. Like, that .047, where was that from?
The what?
The .047.
0.047. That's all of this. Yeah, because you already have this in your calculator. 1.6 times 10 to the 5 negative. You got to push log, right? And then you got to take it times a negative 0.0592 times 0.0592. Then you got to divide it by 6, 0.047. So it wouldn't make much sense to make that intermediate steps.
So then you do, first you get the log answer.
Yeah.
And
Then you do the outside part. Yeah, you have to do the log stuff first. Okay? Marlena, you guys got it? Okay, no problem? Okay, so we're good on it. Bianca. Just add 0.35 plus 0.047. You have to take this 0.01 cubed divided by him squared, push log, times him, divide by him. Right? Okay. You got it? Now the real power of electrochemistry is what is the concentration of this enzyme, this glutamate, this compound in this person's brain at this moment in time right now. They just ate a banana, and then their bananas are really bad for them. Who knows? I'm just making up a story, right? They're going to go into shock. And this little sensor is supposed to say, you better go call a hospital, right? That's what's really important. It's what's the concentration of this stuff right now. If you get the right electrochemical cell, you can monitor pretty much anything. That's what this kind of question is. Let's find the concentration of something. Okay? So we've already, this is one type of answer. Oh, we didn't quite finish it, though. You're going to lose a point if you don't put units. Volts. Okay. So here, we want to solve for the chloride concentration. Now I can see in the very end, the very last step, this is what I can see myself setting up. I'm going to see myself setting up the concentration of chloride. It's going to be a lot of work to get this. Squared is going to be some number. Then I got to take what on both sides? Square root. I can see that being the last step. But how are you going to get there? What would you do first? Yeah. I would clean this up first. Get this over here. I would do that first. Then what would you do? What Brittany was doing when she shouldn't have been doing it in the first one. She was cross-multiplying. Get log equals a number, right? Do the cross-multiplying thing. So you get the log of this 0.02, or a concentration of chloride squared, is some number. That's what you'd do next. Do that cross-multiplying stuff. Then what would you do? Raise it to the 10 power. Right? Right? Because you got to get rid of the log. Everyone with me so far? Raise it to the 10 power. Okay? You have the 10 power. Then you do what?
Then you divide the 0.02 by that incredibly large number that you
Yeah, the cross multiplying thing again, right? Bring the chloride squared where the 10 is and the 10 down to the bottom. Do the cross multiplying thing again. And then we'll do the square root thing. Right? See if you can get it. Right? So first clean it up like what Brad was suggesting. Bring that negative, that 1.23 over with a 0.25. You're going to end up with a negative number. Right? So 0.25 minus 1.23, that'd be the first step. I agree with that. Then do cross multiplying. Then get rid of the log. Then you can finally solve for chloride.
Okay, I don't understand. What's the first cross multiplying?
Okay, so let's see, you have this number
Yes.
equals this.
Right.
Okay, so that means
it's a
this has to
negative.
go. This has to go on the bottom.
Yeah.
This has to go up on top.
I understand
So
that.
2 times 0.98. This is on the bottom, and then fix that. You can have a number equals the log.
Okay, so 0.98.
Yep. I'm not sure. Just keep going. See if you can get a final answer, and we'll see if it is right. I don't know what. Yep. No, Carl, you do. I would fix all this. Get numbers for all this. Make your life easier. See what that number is, right? And then you take it times 2. Well, you see what this is. This is exactly right. See what all this is. 10 to that power. Get that number, and the chloride goes up on top. This, whatever this thing is, goes on the bottom. And take the square root. But I think you'd have a lot less writing, Naya, if you just wrote numbers in here right in the first place instead of that. But it's exactly right. Keep going. What did you get? Yeah, jeez. Okay, I'm going to do the first step. 0.25. 0.25 minus 1.23. A negative 0.98. So hopefully you're writing this for your first step. Okay? So you write down all these little guys. Don't skip anything. Okay? Everyone agree with that first step? And now we do the cross multiplying thing. Bring the 2 up there with the 0.98, divide it by the 0.0592. Notice our negative sign is going to go away. So I have to take 0.98 times 2, divide it by 0.0592. I get about 33.108.
But do you put you don't put the negative?
Negative's gone.
You do, right? Oh, right, okay. Yeah, I got that.
Okay, there's my next step. Okay, everyone following me so far? If you didn't get it, can't get that part right here. Yeah, you have a negative on both sides. It's like, and you can plug them in the calculator. Take a negative 0.98 divided by a negative 0.0592. It's gone. I'm not there yet. I'm trying to make sure I don't lose anybody. And 2 goes up. Yep. Okay. Now I have to raise both sides to the 10 power. Okay. Just raise it to the 10 power. If you had a negative sign here, it would be 10 to the negative. But there's no negative signs. You can't stick one in there. Right? Okay, so now I'm at 1.28 times 10 to the 33. Okay. Now I'm going to do that cross multiplying thing again. Bring the chloride squared up where this big number is. Bring him down to the bottom. Right? Chloride squared up where the big number is. The big number down where the chloride was. Cross multiplying. .02 divided by 1.56 last step, square root. 3.95, like it's 3.9 or something, or 4. Around 4 times 10 to the negative 18. Just depends on your rounding. Yeah, around, I just rounded it. Okay? So I think this is the real power of electrochemistry right here. Any moment in time telling you how much, just by reading a voltmeter, telling you how much concentration there is of something. In anywhere, inside a fish, inside your gut, anywhere. Really powerful. Now you got to put units on here. Big M. Good. Okay? Everyone comfortable with this kind of stuff? We'll have more to practice on. Just want to make sure you can see how to do it. You just got to get used to doing this cross multiplying stuff, right? Just got to get used to doing this kind of stuff. I think. Go, you can move anything along the diagonals, anything you want, right? Feel free to do that. That's the cross multiplying. So let's check out this first question. Find the answer was 4 times 10 to the negative 18. Find the EMF of the following cell. Okay. Find the EMF of the following cell. What's EMF? Yeah, that's your volts. They called it electromotive force, but, right? It's your E cell, right? It's going to be one of these. It's going to be the second one. Why? It gives us concentrations, because they're not all 1 molar. Right? And if it's at equilibrium, we can use the first one. But we have to use this one. Good. You have to use Q. We don't have everything as 1 molar. So we said it was E cell is E0 cell minus 0.0592 all over N log of Q. Okay. So Jasmine, what should we do first? This is our answer right here. That's our answer, right? Okay, let's put the concentrations in for Q. But what's your Q? Products over reactants, but what are they going to be? See what I'm saying? For my brain can't skip all that. I'm stuck doing it this way. You could, if you can jump ahead, you can look at that cell notation and you can identify what the reactants are. You can identify what the products are. You don't have to go and write out these, but you're going to have to anyway, I think, because you have to find out what?
Oh, N.
The N. You have to find out him anyway. So you might as well just write out the half reactions. You're going to have to find out what N is. Right? So you might as well. So I would write those half reactions. guess we could write them over here. I can write them over here. Okay. So hopefully you set up your, right, just from the cell notation you can identify what things are. Okay. I should put my little S on my PB. And you can find the half reactions. Okay. Yeah, look up in any of the previous days. I'll give you a whole bunch of tables.
On that table, is it 0. Or negative 0.13 for the electron?
First one, yeah.
Is that what it is? 0.1?
Good. If you're writing a positive 0.13 for the first one, you're doing this right. Right, for the lead, because you have to flip them. He's flipped in the table. Okay.
Oh, yes. That you're saying.
Kelly, did you find the E0 for the copper?
We need
0.52. Everybody agree? Okay. It's because you have to, it has to be exactly this way, because those reactants and those products have to be what the cell notation said they are. You have no choice in the matter. So you add the two up, you get about 0.65. Okay. Oh, we have to multiply. The electrons aren't going to be canceling, so. Right? Multiply the bottom one through by 2. Do I multiply the E0 times 2? Nope. Like density. Doesn't matter how much stuff you have. Okay. So my electrons will cancel out on me.
I'm sorry, we've only got 0.15 for the copper.
Yeah.
0.15.
0.15.
Oh, you're thinking.
Copper plus. Make sure it's Cu plus going to Cu solid.
I got
So many
0.34.
tables. It's 0.34. Sorry, we're wrong again. Fourth time is going to be the charm.
Okay, but does it matter with the charges? Because that's Cu to Cu2 plus, not Cu to Cu.
You have to match this exactly.
No, that's wrong.
So you have to find Cu plus an electron goes to Cu solid. That's a 0.52 volts.
Who made this question?
All right, it's in your table. It's got to keep looking to find it. Everything has to be Cu plus going to Cu solid.
I don't know. I broke it down like you did. That's why
Okay.
I mean, just like minus plus minus, right?
Yeah, okay.
And such a big ball.
Yeah, no, it's fine. I got it. I don't know. This is right. The
Yeah.
0.52 and the 0.15.
Mm-hmm. 0.13 and 0.52.
So we're saying that 0.52 is correct.
Why, you can't find it in your table?
I found it. I got 0.34.
Well, you got to find a complete table, right? Open up to day 34A or 34B.
Should be right there.
All right.
The only one that was close enough to it was
Yeah,
That's 2 electrons. That's 2 Cu solid. You can't use that.
It is too solid.
Look.
Yeah, but it is a solid.
Electron plus Cu plus goes to Cu solid.
It's on this.
That's
It's on this piece of paper. It does have 0.50. That's
Oh, I don't have that paper.
Yeah.
I turned it in
Miss
with my
Christina,
kids.
yeah. Miss Christina kept it.
Oh no. Okay, I screwed up.
Way to
So-
tell times on her.
so you.
I got it. Yeah.
The half reacts. There's some confusion on looking up these E0 numbers. This has to match verbatim in your table. If the table you have doesn't have it, then you got to find a table that does have it. It has to match verbatim. It has to be Cu plus going to Cu solid. It has to be exactly the same. And you will look it up and you'll see it's 0.52 volts. Okay? Now what are you going to put in for your Q here? It would be what over what? 0.01 all over close. Just forgot to do what? Because she's right, solids don't show up. Yeah, where did the 2 go? It's the squared. Right. In fact, what we probably should have done, so we don't skip any steps, you don't get confused, it'll be lead all over Cu plus, but squared.
Did you do the whole thing?
Right? Okay.
That's not how we did it on this one.
Okay.
Why is the 0.8 squared? And how do we know it?
Right?
Oh, because,
It's 2 Cu plus. I mean, it's products over reactants. So we leave solids out, great. But if you have a stoichiometric coefficient, it becomes the power. Okay. So I'm take 0.01 divided by 0.8 squared, hit equals, then log, then times 0.0592, and that's negative, divide by 2, hit equals, and then plus 0.65. About 0.703 volts. About 0.7 volts. Okay?
7, 0.
Yeah, somewhere around there. Depends how much rounding you did.
I get 0.703%.
Okay?
Okay, find this first, then log, then multiply by 2, then divide by negative this, and then add this, right?
Mm-hmm. So yeah, so you should get, just like we did in the first question, find what's inside the log first, then take log of it, times 0.0592, divide by 2. Remember, he's negative. Add a 6.
Times 0.0592.
Whatever. This is a number. This is a number. Think of that as a number that you have to find first. So that number, you have to take times 0.0592, divide it by 2. Right? The log of something is just a number. And you have to find it first.
When there is no phase noted, we should assume it's aqueous.
Ions are always aqueous. But the tables are always say the states really well. Liquids you leave out, solids you leave out of equilibrium constants and Q expressions. Okay. Okay? See if you can set this one up. Find the EMF of the following cell. Okay. Same equation.
Make sure you won't wait for it.
So I would set up those two half reactions. So that way you can get your Q expression. You can figure out what little n's going to be. And you might be able to tell just by looking at it what little n's going to be. It's going to be 6. Yeah. And you can tell just by looking at the cell notation really what the Q expression will be, but it's skipping a lot of steps, and it doesn't take very long to figure out what the overall reaction is. So I suggest finding it rather than trying to skip stuff.
Do you divide it by 6 first and then multiply? You give a log, right? What did you get guys get?
Okay, there's my setup equation. I got an E0 cell to be 1.08 volts. The number of electrons that canceled was 6. Okay, these are the stoichiometric coefficients. It's just, no, you're looking at your overall reaction. Whatever the numbers are in front of there. Products over reactants.
Oh, okay.
He's a 3, and he's going to be a 2.
So basically is that?
Well, yeah, but you got to be careful, because sometimes, what if
Because I
he's...
was looking at this one outside, and then I
Because
saw-
what if this is a 2? Then you multiply it by 2, now it's a 4. Products over reactants, you have to be a 4. So you don't want to take any chances. Did anybody get an answer? 1.1 volts. Anybody else get 1.1? 2 people got it. It's got to be right. Jacqueline, did you get it?
I got 1.09, but if you're out.
1.1 volts.
How did you get the E-cell? Can you tell me the number you used?
For E0, for 1.08?
Yeah.
I looked up 0.74 and 0.34. Now you got to be careful. These guys, they're really easy to screw up because if you don't pick up, make sure it has copper solid in it, copper +2 in it, and it's written the right way. Well, put a piece of paper under there. I'll line them up. All right. Oh, we're out of time. You got bonus minutes today.
Does that equate to bonus points?
No.